In this video, I'll teach you a method called proof by contrapositive. So, firstly, sometimes you won't get what proof to use, but if it doesn't make sense, it most likely proof by contrapositive. For example, prove if 5n plus 3 is odd, then n is even. So prove if 5n plus 3 is odd. So if we make that odd, how on earth can we prove n is even? Think about it, do it, you just can't. You're dealing with so much of work to actually prove that. So here's the thing. Proof by contrapositive basically means this. So remember, we have two statements here. The first statement is prove if 5n plus 3 is odd. Second statement, then n is even. So if we represent this as P and we represent this as Q, so P implies Q. What contrapositive is? It's not Q implies not P. Now you don't have to know this, but like I'm telling you so you understand what I'm doing. So these are nots, right? So basically this is what I got now. But if I change it to this, firstly I'm switching this with this statement. That's the first thing I'm doing. So put Q there, put P there. So right now I'm saying then n is even, prove 5n plus 3 is odd. But it's not. So when I take this in the first sentence, it changes. So n is odd. So basically let me write this down so you understand. So basically what I got here, it's to change it now for my contrapositive, it will be n. So n is odd. It's basically n is not even, but not even is odd. Then you take the first statement and the opposite. So 5n plus 3 is not odd, so it's even. So this is what I'm going to prove. Now if I do this, you'll see I can do it. So that's proof by contrapositive. Now for me to start with this proof, I need to construct what I want. And to construct what I want, I need to make this, as I need to assume something for n. So to do this, I need to say proof. So we must just write the full proof down, like the word proof. And then suppose something. So we want to make the statement this state. Now what we did here is basically we made this now like a direct proof. So contrapositive is basically taking a statement and making it in a direct proof. So suppose. So you need to suppose the n. Okay, so suppose. Okay, so n is odd. Suppose n is odd. Then you have to make it like, if n is odd, what will n be? It'll be 2 times something. Always it'll be this. Plus 1. It can be any letter. It depends what you want to do. Now, you have to write such that k is an element of integers. This case I can just put it in brackets, k is an element of integers. Now, n is odd, then 5n plus 3 is even. So basically you have to replace n over here with k plus 1, 2k plus 1. So this implies 5 times n. Now in this case we made n 2k plus 1. So 2k plus 1 and then plus 3 there. So now 5 times 2k, that implies 10k plus 5 plus 3. Now to simplify this over here, it'll be 10k plus 8. So if you simplify it, 10k plus 8. And now we have to make it similar to, we want proof that is even. So we can take out a common factor here, which is 2. So that'll be 5k plus 4. And right now we proved it, but wait, anytime you get this to this point, you make the bracket something, because the definition of an even number, it's like n is equal to 2n. So this we can make it anything. So let's use so let's use m. So now we have to say, so this is what we need to say. where, because we made something m, so we have to say now, okay, what is an m? Where m is equals to this here in brackets 5k plus 4, and basically it's an element of integers. So right now we're done. We proved that by doing this you get an even thing. I mean an even number. So anytime when you're done with a proof, you basically have to do a square, and yeah, that's it. So color in that square. So right now I proved this first statement over here by doing the contrapositive.